To wrap up inverses, let's do one more example problem, and that is with a rational function. Okay, so we have g of x is equal to 1 over x plus 2. So we're actually going to create the inverse g inverse of x this time, of course. So let's start by writing y equals x plus 2 and then switching the x and the y. Okay, so this is our inverse, but we need to solve for our new y. So this y is in the denominator. So the strategy you're going to use is to multiply both sides by that denominator, because that will take care of that y plus 2 in the denominator, right? Because y plus 2 over y plus 2, right, is 1. And this side, we also just have to multiply by the y plus 2 so that we're doing the same thing to both sides. So this is x times y plus 2. And this side is actually 1 because the numerator was 1. So it's 1 times 1. Okay, so now notice that what we're trying to do, right, is we're trying to solve for this y. So we could multiply the x in. That's okay, but then we'd have to divide the x back out at the end. So I think what we instead want to do is divide both sides by x, right? So we're getting y is equal to, let's see, this x divided by this x. Oh, sorry. So it's still y plus 2. Sorry about that. Y plus 2 equals, and then this is dividing by x and dividing by x, so 1 over x. And then to solve for y, we get y is equal to 1 over x and subtract the 2. And we can leave it this way, or we can write it, all together, but I think it's going to be easier to graph if we leave it this way, because 1 over x is our standard graph of rational functions, and then this is just a vertical shift, right? So let's leave it that way, and let's write that our inverse then is the inverse, g inverse of x is equal to 1 over x minus 2. And highlight that there. Okay. Now, to graph the first one, this is g of x is equal to 1 over x plus 2. So this plus 2 is in the x's, right? So this is a horizontal shift. And then, let's see, it's plus 2, so it'd be left 2. Okay, so our standard 1 over x graph would be shifted over 2. So I'm going to draw, I guess I'll just keep it all in this purple. I'm going to draw the vertical asymptote over at x equals -2 instead of at 0. And the horizontal asymptote remains at 0 because the y's didn't shift. And then the graph goes through those diagonal points, 1 away from that intersection. Okay. So we have to be familiar with the original graph 1 over x to be able to graph that easily. Okay. Now in blue, let's graph our inverse, which is 1 over x minus 2. And so that would be a vertical shift, and that would be down 2. Okay. So this one, the vertical axis doesn't move, but the horizontal axis moves down 2. It's a lot going on this graph, right? Nothing else changes, so this graph has to go right here and here. Ooh, so much going on. Especially with my difficulty drawing vertical lines. It's like the hardest part of all of this, drawing vertical lines. Okay, so I have one graph here and one graph here. Okay, it's probably a little harder to see that they do reflect over the line y equals x, but they do. I mean, you can kind of see it here. It's a little messy, so it's a little hard to see that. But every point over here matches with a point over here that has the reversed x and y values. Okay, and We could look at the domain and range, right? Maybe maybe we'll skip it, right? I guess if we wanted to real quick, that's a good idea. So in the purple, the domain, right, is every number except x is equal to, x cannot equal -2. So we'll just write it that way just to save time. So we know that x cannot equal -2. We could write it in interval notation or be fancy, but really we know x is every number except -2, and the range, notice that the horizontal asymptote is at 0, so it's y cannot equal 0, right? And then let's contrast that with the inverse. So for the domain for the inverse, let's see, it's in blue. We did not move the vertical asymptote, so x cannot equal 0, right? And the range for the inverse was shifted down 2, so the y values cannot equal -2. See, confirm how these switched, right? The domain x could not equal -2, and now in the inverse, the range y cannot equal -2. Okay, so that kind of confirms what we were talking about before. So just a little summary, all inverses reflect over the line y equals x. We've seen that every time. The domain of the inverse is equal to the range of the original function. Okay, and the range of the inverse is equal to the domain of the original function.